that's where we have stopped last time. We discussed the things in the second lesson until the central processing unit, as I remember. So like we get to know that this central processing unit has three components, which we have discussed already, right? Which is the control unit, ALU, and the registers, right? So it is the place that we have stopped last week. So we get to know, like we wrote down about the arithmetic and logic unit, the control unit, and the memory registers. And we have discussed this particular matter with the von Neumann architecture. I showed you the previous time that we talked about it. So then we had the discussion and we wrote down the things. And I think we haven't mentioned about the computer speed, right? So which is a part of this central processing unit, the speed, right? So speed of the computer is measured, or like when we're talking about the speed of the computer, we always talk about the speed of the processor, right? CPU එකේ තියෙන speed එක ගැන තමයි අපි කතා කරන්නේ, right? So speed of a computer, like there is another name which called clock speed as well, right? Clock speed එක කියලාත් අපි කියනවා. So it is measured by the unit which is called the hertz, right? So hertz means per second. The meaning is per second. How many things happens per second, right? So it's a measurement of a frequency. So when it comes to the CPU, what is the frequency that we have to measure is the number of instructions that is executing per second, right? So when it comes to that, in a modern computer, a modern CPU executes billions of instructions per second. So illustrating that speed with the hertz will give you a very big number with a lot of zeros, right? So because of that, they are using gigahertz, which is a bigger unit, like when it compared into like when it comes to the gram. So the kilogram is going to be a bigger unit, so your number will get smaller, right? So like 1,000 grams we indicate as 1 kilogram. So likewise, the billions of hertz is reduced into a 1 digit, right, using the gigahertz unit, right? Previously, before it becomes the gigahertz, it's become megahertz, like the older technology, like 10 to 15 years back. If you think about the processor or the CPU, the speed measure using the megahertz, right? Because on those days, right, so like I'm talking about early 2000s, right? In those days, millions of instructions were executing per second. So it was measured with the megahertz. But today, it's 1,000 times greater than the early 2000s. So nowadays, we are like referring the gigahertz because it's executing billions of instructions per second, right? So let's like write about the computer speed and then jump into the memory, right? So today we have to talk about the memory, right? So before that, please copy this down, the entire thing regarding the computer memory. And people, meanwhile, there is a good news. We will be able to meet up physically by next week, right? So Nanapeta is starting their physical classes. So by next week, we are meeting on the same day, but from 6 to 8, right? Not 6:30. It's from 6 to 8 at Nanapeta, right? Online classes නෑ එතකොට ලබන සතියේ ඉඳලා. Let's hope and pray this is going to continue usually, like in a normal manner, right? අපිට දිගටම කරගෙන යන්න පුළුවන් වෙයි කියලා අපි හිතමු. So එතකොට යාළුවන්ට පණිවිඩය දෙන්න 6 ඉඳලා 8 වෙනකම්, තමයි English medium class එක තියෙන්නේ, right? So this will be officially the last online class that we are having, right? So yeah, I'm excited to see you all. And I hope you have the same expectation. So let's meet by next Friday. It's going to be a physical class, and people, when you are visiting to the Nanapetha, you have to take care of yourself and the others according to the COVID virus preventing instructions, right? So you have to wear a mask and you have to keep the distance of 1 meter, right? And you have to like you should not like get together like you do in the previous days, right? So distance එක තියාගන්න 1 meter කියන කොළුවේ තියාගන්න, right? තැන් වල එකතු වෙලා ඉන්න එපා. When you are sitting, you should have the distance, right? And you should wear a mask always, right? It is very like Nanapetha and the people who are from the this health sector will be monitoring like time to time. So you have to be very precise when you are inside the institute. So then we can continue, right? And in other in other hand, we have to have the responsibility to taking care of yourself as well as others, right? අපි ගැන හිතන්නත් ඕනේ, අනිත් අය ගැන හිතන්නත් ඕනේ. So please wear a mask and come and keep the distance, right? So මම class එක ඉවර වෙනකොට මතක් කරන්න that we are starting the physical classes. So like inform to your friends as well, right? If they are, if anyone is absent in here, right? So try the computer speed note. So let me know when you are done. Right, are we done, people? Right. Right, okay, so let's move forward. Okay, so the fresh means like the next sector, it is the computer memory, right? So the computer memory, like when it comes to the memory, we are going to talk about how computer memorize things, right? So when it comes to memorizing things inside a computer, there are two ways of memorizing things, which are permanently memorizing or like storing permanently and storing temporarily, right? So keeping it for temporary manner, right? So on this aspect, the permanent storage devices or like permanent memory devices, we call them the volatile memories. I'm sorry, non-volatile memories, right? And the temporary people, we address them as volatile memory. Like volatile means like until voltage is given, right? So in simple words, until the power supply happens, they keep the things in their mind. So those are called volatile memories. So when the power supply is gone, whatever that they are holding is erased. So they call volatile memories. And there are some other, it doesn't matter whether they got the power or not, they are going to remember that anyway. So those are called non-volatile memories, right? අපි සිංහලෙන් කියනවා නශ්‍ය වන මතකය, volatile memories නැති වෙන මතකය, non-volatile memories නශ්‍ය නොවන මතකය කියලා, right? And again, as per to your book, it can category into these two categories as well, like main memory and the secondary memory, right? So main memory, actually main memory includes three things, like three different memories. They only illustrate you two: random access memory, which is the RAM, and the read-only memory, which is the ROM. Other than this, there is another memory called cache memory, right? So actually the main memory is divided into three parts, which is the cache memory, random access memory, and the read-only memory. And when it comes to the secondary memory, like other than the cache, RAM, and ROM, all other storage devices are category inside the secondary memory. So starting from hard disk drive, all the storing devices like the pen drives, CDs, DVDs, and all these things are category under the secondary memory. Right, so before we move forward, let's get down these two things, right? So like have the heading computer memory, right? And you better draw this structure, right? And when you are drawing it, please have a new category under the main memory, which is called cache memory, C-A-C-H-E. That is how the cache is written regarding to the computer, right? It is not C-A-S-H, C-A-C-H-E, cache memory, right? So main memory got three categorizations, which is the cache memory, random access memory, read-only memory, right? So let me take a screenshot and write the thing. Otherwise, you will forget the thing, right? So you should have another category which is called cache, C-A-C-H-E, cache memory. Right, let me know when you are done, people. Right, few are done. How about others? Right, so let's move forward. Okay, is there anyone still finishing the things? Is there anyone? So please let me know. Right. Okay, so let's move forward. Right, now the thing is, when it comes to the computer memory, so we are talking about the main memory for the first time, right? So the main memory, in other words, the primary memory they address. So it is, as I told you, majorly divided into three parts: cache memory, random access memory, and the read-only memory. So here what we are talking about is the random access memory. Now, when we meet next class, I'll show you how a random access memory, like what is a random access memory. Maybe you have seen a one, but I'll bring you one, right? So you can touch and feel how it is, right? So RAM is the word, like we always use this word called RAM when it comes to the computers to initiate or like to mention about the memory, right? Like most of you have the experience about the RAM with the experience of the slowness of your computer. වගේ computer එක slow වෙනවා නම් ඔයා නිතරම නේද ගොඩක් වෙලාවට කතා බහ වෙන්නේ උගලෝ RAM එක මදි ඇති කියලා. Right? It is one of the factors that cause your computer get slow, right? But it is not the only factor. ඒක විතරක්ම නෙවෙයි ඔයාගේ computer එක slow වෙන්න හේතු වෙන්නේ. But most of the time it's the RAM. So why it causes your computer get slow? Then RAM එක කියලා කියන්නේ it is the component, the hardware component which remembers the things until your data is being saved, right? So when you are using any program, right, it doesn't matter whether you are using a word processing software or presentation software or a game or any kind of things which you are about to save, like everything will be there without saving inside your computer for a moment. For a moment means like for a while, right? ඔගොල්ලෝ game එකක් play කරනවා නම් until you reach the next stage, the game will not be saved, or otherwise inside the game the saving option is given. Until you save it, game will not be saved, right? As well as if you are doing some documentation using a word processing software, the word වගේ එකකින් වැඩ කරගෙන යනකොට until you save your file is not being saved, right? So when you are saving the things, that data, that particular data is saved inside the secondary memory, which we majorly it is saved in your hard disk, which is a secondary memory. So until it is saved, everything is there in the RAM. So if your RAM is having some trouble of keeping the data inside it, ඒක හරියට අර අපේ මතකයට ගොඩාක් දේවල් මතක තියාගන්න කියනවා වගේ. එතකොට අපිට නේද අපිට සමහරලාට මොකද්ද කරන්න කියලා හිතාගන්න බැරි වෙනවා. So same happens to the RAM. If lots of data comes into the RAM at once, the RAM will not be able to handle that thing. නේද? එහෙම වුණාම එයාට හිමින් තමයි පොඩ්ඩක් figure out කරගන්න වෙන්නේ කාවද මන් දැන් තියාගන්න ඕනේ කවුද මන් දැන් තියාගන්න ඕනේ නැත්තේ කියන එක. So for that reason your computer will get slow until the RAM process the things, not actually the processing, until the RAM figuring out the things, like what to be done with the things that it is being loaded into that, right? So however, if you execute a program, it always loads into the RAM. RAM එකට load වෙන්නේ නැතුව එකම program එකක්වත් run වෙන්නේ නැහැ. Even your operating system, when your operating system is being boot computer එක first time on කරනකොට, the very first software that is loaded into the RAM is the operating system, which we generally use the Windows, right? Windows ඊළඟට phone එකක් on කරනවා නම් Android operating system එක, if you are working with an Apple computer, the iOS, right? So whatever the computer or whatever the device is getting on, first the operating system will be loaded into the RAM, right? Then if you are using any application, again that particular program will be loaded to the RAM, then you will be given the ability to work with it. So remember, without a RAM, you have no idea or you have no capabilities to work with any application, right? RAM එක නොතිබුණා නම් ඔයගලන්ට වැඩ කරගන්න වෙන්නේ නැහැ. මොකද එතනට load වෙලා තමයි program එක run, right? So RAM is critical in that manner, and again remember, RAM is volatile. That means until the power is supplied to the computer, RAM will memorize the things. Once the power is disconnected, RAM will erase the things, right? Without asking you, like if you disconnect the power, there is no one to ask, so it will just erase the things. Like you may have experienced this thing with a mobile device. නේද? ඔයගොල්ලෝ game එකක් play කර ඉන්නකොට sometimes like mistakenly, if you are not concentrating on the battery power, like at the middle of the game, your phone may get off, right? Off වුණාම මොකද වෙන්නේ? ඔයගොල්ලෝ ටක් ගාලා charge එකට ගහලා phone එක on කරගන්නවා ඉක්මනට. But the thing is, you can't start the game from where it has been discontinued, right? යන අතර වෙච්ච තැනින්ම ඔයගලන්ට පටන් ගන්න බෑ. So if you are going to play that game, so you have to start it from a place where you have saved the game previously, right? So the reason is, until you save the game, it was in the RAM, so power got disconnected means there is no reason for RAM to keep the things in it, so it erases. That is the nature of the RAM, right? So remember, RAM is important and it is volatile, right? Okay, so let's first take down the things about the RAM, right? All right, so this is the way you are going to write it. So write the primary memory, and it's better you write, hold on. Yeah, it's better you write the entire thing, like put these particular 2 sentences, right? Then put the subheading called random access memory within brackets RAM. Right, one is done. How about others? Okay, right. So you have to put the subheading random access memory within brackets RAM and put a dash and open a square bracket and say volatile memory, right? Within a square bracket, like just after the random access memory, put a dash, right? Once you're done with the heading, put a dash. It's going to be a part of the heading. So put a dash within square brackets, say volatile memory. Right. So the very first point, so you better write it like point forms. This is going to be your very first point. Right, so the second point is going to be like from this point onwards, right? So the very first sentence, then after there are two sentences here in the highlighted area. So write them as 2 points. Points දෙකක් විදිහට ලියා ගන්න. ඔය වාක්‍ය දෙක. Right, let me know when you are done, people. Right, 2 are done. Okay, so let's move forward. So the next one is the ROM, read-only memory. So from the name you can understand read-only memory. So it can read. We can only read that. The computer can only read, not write. So like in the previous one, RAM, it can be written as well as it can be read, right? ලියන්නත් පුළුවන් කියවන්නත් පුළුවන් RAM එක ඇතුලේ. Right, ඒ කියන්නේ data එයාට දාන්න පුළුවන්, අලුතෙන් එන්න පුළුවන්. ඒක තමයි අපි write කරනවා කියන්නේ. RAM එක උඩ තියෙන data එකක් read කරන්න පුළුවන්, කියව ගන්න පුළුවන්. So it has both the abilities, but when it comes to the ROM, like computer can only read what is inside it, but it cannot write things into it. ඒකට අලුතෙන් දේවල් දාන්න බෑ. So ROM is something special, right? So as the picture shows, it is like weld onto the motherboard. Motherboard එකට එයා weld කරලා fix කරලා ඉන්නේ, and the ROM is made by the manufacturer, right? Like we can't adjust the ROMs, or like we can't fix the ROMs onto the motherboard, right? දැන් ඊළඟ දවසේ ආවම මම motherboard එකකුත් පෙන්නන්නම්, right? So you can have the experience. So ROM is fixed onto the motherboard, and the manufacturer is including particular instructions into this ROM, saying what to be searched or what to be assured when the computer is booting, right? It is one of the aspects, right? එක වැඩක් තමයි යට තියෙන එක. So ඔකට අපි ගොඩක් වෙලාවට කියනවා BIOS කියලා, BIOS, basic input output system එක කියලා. So like BIOS are written into the ROM and fixed onto the motherboard. So BIOS will do what? According to the instructions given to that particular chip, it checks the computer when it is getting booted. boot වෙනවා කියලා කියන්නේ first time computer එක on වෙනවා කියන එක. First time කියන්නේ අපි computer එක power on කරාම සිද්ධ වෙන දේවල් ටික. Right? අපි computer එක දිගටම on කරලා තිබ්බොත් only one time it get boots. we use the computer, and when we shut it down, then we are starting it. So again the boot up process happens, right? So those instructions, those special instructions are given or like stored into the ROM by the manufacturer, and then the ROM is fixed onto the motherboard. So then it will check, or it will do its duty when the computer gets starts, right? So what you have to remember is, unlike the RAM, it does not have the ability of getting right things into it, but the machine has the ability of reading what is inside the ROM and executing what it has said. And again, remember, when it comes to the ROM, it is done by the manufacturer. We can't like take the ROMs and fix onto the motherboard, right? So that is why it is called read-only memory, and it is the instruction inside the ROM is not going to erased when the power is disconnected, right? එහෙම වුණා නම් practically වෙන issue එක මොකද්ද? Power disconnect වුණාම ROM එකේ තියෙන details මැකුණොත්, so then computer එක boot වෙනකොට බලන්න ඕන instructions ටික ROM එකේ නැහැ. So then it will give us an error. Right, මොකද ඒක boot up process එක හරියට වෙනවද කියලා assure කරගන්න තමයි ROM එක ඇතුලේ instructions තියෙන්නේ. So the instructions inside the ROM is not going to erase. Now when you see the motherboard in next week, you will find there is a place to there is a special socket to place a battery, a small battery. හරියට wristwatch battery එකක් වගේ ඊට ටිකක් ලොකුයි. එහෙම battery එකක් දාන්න තැනක් තියෙනවා කියලා. Right, we call it the CMOS battery. So that battery powers up these kind of ROMs not to erase the things inside it. right? ඒ බැටරි එකෙන් කරන්නේ මේගොල්ලන්ට දිගටම power එක දීගෙන ඉන්නවා. ඒගොල්ලන්ගේ කියලා තියෙන දේවල් අමතක නොවෙන්න නැතනම් මැකිලා නොමැකී තියෙන්න. Right? So because of that, we call ROM is a non-volatile memory. RAM was a volatile memory and ROM is a non-volatile memory. Right? Okay, let's write about this. So read, put the heading, read, I mean the subheading, read-only memory within brackets ROM. And like we did previously, put a dash within the square brackets, write non-volatile memory. Non-volatile memory. Right? So under that, this is going to be your first point, the very first sentence. Right, so the very first line is going to be the very first point. And the second point is going to be the third sentence of it. So this is the first point, finish with it, then I'll show you the second point. Okay, the second point is going to be this: the commands required for booting up a computer are stored in ROM. That is the second point. So the very first sentence is the first point, then this is the second point. Right, and the third and fourth points are going to be these two lines, and the very last line, it's better you stop in here. Computer manufacturing companies stores these commands in a ROM, like from there. So the third one is going to be these commands are called BIOS. The fourth one is going to be computer manufacturing companies store these commands in a ROM. Let me know when you are done, people. One is done. Right, two are done. Right, so let's move forward. So the next one is the cache memory. Now this cache memory is a very special memory, right? Now, if you ask me where the cache memory is in a modern computer, cache memory stays inside the CPU. In other words, central processing unit or inside the processor. But when they introduce the cache memory acts as the mediator in between the primary memory and the CPU, like your book shows in this diagram, right? So CPU is there, primary memory or the RAM is there, and cache memory stays in between. So that means cache memory is more closer to the CPU, right? And comparatively, main memory is a little bit distant from the CPU, right? So why there is something called cache memory? Because cache memory has the ability to remember or to store which kind of programs or what is the programs that has been executed inside the CPU recently. නේද ළඟදිම CPU එක ඇතුලේ execute උනේ මොනවද? Right? So there is a benefit of storing these kind of data. It's like when you are starting the word processing software or word කියන එක on කරොත් for the first time, it will take some time to get on, right? But if you close the word, then if you reopen it, it will get open quicker than the last time, right? කලින් වතාවට වඩා ඉක්මනට open වෙනවා ඔයා close කරලා on කරලා, right? The reason is the cache memory, because cache memory remembers what has been executed recently. So when CPU is asked to execute the word, before it looks into the RAM, it looks to the cache. මොකද cache එක තමයි ළඟ. එතකොට CPU එක බලනවා cache memory එකේ data තියෙනවද මේ program එක execute කරන්න. Right? That's what this picture says. Check cache memory to see whether there is required data. So if the data available inside the cache memory, it will straight away take those data from the cache memory. So the execution get in quicker. ඉක්මන් වෙනවා execution එක. In case cache memory does not have the required data, then it will refer to the main memory, which means the RAM, right? So anyway, RAM is going to have the data, because when something asks to execute, From the hard disk, the program will be taken into the RAM, right? So then it checks the RAM. RAM will produce the data to the cache, and cache will produce the data to the CPU. So then it is executing in the traditional way, right? So remember or get the point why the cache memory is there. So to act as a mediator, and it will like quicker the process of execution, right? Okay. මට පොඩ්ඩක් confirm කරන්න clearද කියලා කියපු දේ cache memory එක ගැන. Right. Great. Okay. So let's write about the cache memory then, right? Okay. So have the and people, cache memory is a volatile memory, right? Like the RAM. So cache memory මතක තියාගෙන ඉන්නේ current එක තියෙන කාලේ, power supply එක තියෙනකම් විතරයි, right? So when you disconnect or when you off the machine, cache will erase the things inside it, so it will become a very fresh and empty place. So then after, when you on the machine again and run it, so then cache will is going to fill the space, right? So cache is volatile, right? So RAM is volatile, cache is volatile, ROM is non-volatile, right? Okay, so write the heading cache memory, then you are going to say in front of it, put the square bracket and say volatile memory. So cache memory, then put a dash or without a dash, it doesn't matter. Within the square brackets, say volatile memory. So as usual, the first line is going to be the first point. Right, the second point is going to be this. And third point is going to be the next. So in the highlighted area, there are two sentences. Write it as the second and the third points. Right. Inupama, I really don't get what you are saying though. Like what do you mean by like neat office document though? I really don't have an idea about that.
Is the apple that combination of it.
Though your voice is not clear though, it's lagging actually in this side. Can you just type it for me? Risara, when it comes to the features like cache memories, they are to like remember the frequently running programs, right? So uh, that is the best feature it is given us. It memorizes the things which are being like executed frequently. So then CPU will having the help or like will having the benefit of executing that particular programs if it is being asked to execute again, right? Time එක තමයි reserve like free කරන්න ඉතිරි කරන්න save කරන්න, right? Okay, so the first 3 points are written, and the fourth point. No, you don't really know. No need to go for further points, but people just have the space to draw this diagram on your book, right? That is going to be a homework, right? So leave some space to draw this diagram, right? Right. Okay, Nupama. Though I really don't have the experience regarding that particular software, though, I haven't worked with it. So, in that case, I really don't know what is going to be the problem. Was it working previously, like without a problem? Like, was it recent that it is not being loaded? Yeah, tell me the instructions. Like we are talking about this when it comes to the operating system. Listen, but I will brief you here. Inside the ROM, like when it comes to the BIOS chip, basic input output system chip, which is a ROM, it has the instruction of assuring some components before the computer get like loaded, or like before the computer get boots. Like it has to. There are instructions to check the CPU temperature. There are instructions to be check whether the RAM which are being installed is okay with the computer. There are instructions to check whether all the input output devices are communicating with the computer in a correct manner, in a proper manner. Even it checks whether a keyboard and a mouse is connected to the computer or not. So there are some basic instructions are there for to check the computer, like to check whether it is ready to be served to a user, right? So those kind of instructions will be there in the ROM, right? Right. So people, if you kept the space to draw this diagram, right? So we'll move forward to the secondary memory, right? Okay, so when it comes to the secondary memory, it actually consists of three categories. Right now, secondary memory is a memory which stores the data permanently. So, in other words, it's going to be a non-volatile memory, right? So, there are categories according to the Ranuja, I'll come to your question, right? According to the way it stores the data, or like the technology that they store use to store the data. So the categories are going to be like magnetic media, optical media, and solid state devices, right? So like magnetic media means they use the magnetism to store the data inside these devices, right? So the traditional hard disk, I'll tell you why I say it a traditional hard disk. And there is something called floppy disk, which is a very low capacity component. Like if you take about the capacity of a floppy, it's going to be 1.44 megabytes, right? So it is something that cannot store an MP3 song, but still there are many occasions where we use floppy disk to have the, or like to take some benefits out of it, right? And there is another one called magnetic tape, which is not very familiar with us, but if you have seen a tape which you use inside the tape recorder, cassette එකක් දැකලා තියෙනවා නම්, so inside that cassette, the ribbon kind of a thing, we call it the magnetic tape, right? So that those three things, like those three things, plus there are many other as well, are called the magnetic media devices, right? So the specialty of this type of devices is it need a component called head එක කියලා එකක් ඕනේ to read the things on these devices, right? I'll show you how the hard disk head is working, right? And when it comes to the optical media, all kinds of discs, like the CDs, like the DVDs, like the Blu-rays, all kind of discs are category under the optical media. The reason is optical media is burned, or like the data is written onto the optical media like using a burning process. පුච්චන ක්‍රියාවලියකින් තමයි ඒගොල්ලන්ට data insert කරන්නේ. So how it is going to get burned is using a laser beam. So laser beam is there inside the CD burner, right? ඔගොල්ලෝ CD writer එක කියලා කියන්නේ, right? So what actually happens is these discs, they have the surface which is made for writing the data. So once you insert your CD into this ROM, this laser beam will burn your CD surface, the writing surface, into a pattern, right? අපිට ඒක ඇහැට visible නැහැ. I'll show you a video how it happens, right? So according to that burning spots, then after the ROM will recognize how far the burning has happened on the surface. එහෙම තමයි ඒගොල්ලෝ ones and zeros figure out කරගන්නේ CD එකේ surface එකේ දීලා තියෙනවා. يعني ඒගොල්ලෝ එක දුරක් කියන්නේ වැඩිපුර දුරක් තියාගෙන ඉන්නවා, නැත්නම් වැඩිපුර දුරක් burn කරනවා එක indicate කරන්න, අඩුවෙන් burn කරනවා බිඳුව indicate කරන්න. right? දැන් ඔයගොල්ලෝ නිකන් හිතන්නකෝ cheese slice එකක ඔයගොල්ලෝ toothpick එකකින් සිදුරු හදනවා කියලා. right? ඒතර cheese කෑල්ල තියෙනවා ඒක melt වෙලා නැහැ. ඝන cheese කෑල්ලක්. so එයා toothpick එකකින් සිදුරු හදනවා. එතකොට ඔයා ගැඹුරු සිදුරක් හදනවා එක indicate කරන්න. ගැඹුර අඩු සිදුරක් හදනවා බිඳුව indicate කරන්න. so same thing happens. So toothpick act as the laser beam. So like laser beam act as the toothpick, and the cheese slice is the CD. So laser beam එක අර ඔයා සිදුරු හැදුවා වගේ වැඩිපුර දුරට පුච්චනවා එක ඉන්ඩිකේට් කරන්න අඩු දුරක් පුච්චනවා බිඳුව ඉන්ඩිකේට් කරන්න. Right? I'll show you an animation, then you will be having a much clearer idea about what is this burning process is. So because of this, discs are using the laser beam to do its operation. So laser beam is an optical media. That is why they call this is an optical media devices. Right? And when it comes to the solid state devices, the reason it's said it is called a solid state, it does not contains any moving parts. Now you will see, I'll show you a video about the hard disk workings, right? Then you will see there are many components inside the hard disk which is moving here and there. But when it comes to the solid state devices, there are no any moving parts inside it. So the examples that they have given is the USB flash drive, the memory cards. You know about these two, neither. USB එක ඇතුලේ කැරකෙන කරන දෙයක් නැහැ. It's just a circuit inside it. And when it comes to the memory card, again, it does not have any moving parts. It's just a small kind of a chip where you are going to use inside your phones or your like what the MP3 players and all these things. It's just a single chip. So there is no any moving parts. So because of that, it is called a solid state device, right? So three types: magnetic media, optical media, and solid state devices, right? Okay, so before we move to the video, shall we write down this particular thing? So put the heading secondary memory, right? And it's better you put a square bracket and say non-volatile memories. Yeah, and people from this point up to here, it is important for you to write down the things. So it's better you write it like point by point. So there are 3 sentences. So write it like write it as 3 points, and then you have to draw the diagram, right? So first finish up with the what you call the paragraph, like write it as point wise. Binadi, the solid state devices, it's again, why we call it a solid state device? Because it doesn't have any movable parts to it. So when you see the video that I'm about to show you, you will realize what are the movable parts that can be inside these storage devices. So if you think about the USB flash drives, they does not have anything movable. It's just a circuit. Move වෙන කොටස් නැහැ. So that is why it is called the solid state devices, right? So like USB flash drives, memory card, they do not have any movable parts. So it is called the solid state devices, right? And Ranuja, fetching data means like taking the data, right? අපි memory එකෙන් data ගන්නවට කියන computer term එක තමයි fetch කරනවා කියන එක, right? So fetching the data means you take in the data. Right. So if you are done with the writing, I can show you the video. Like, let me know when you are done. Right. One is done. Okay. So it seems everyone is done. So you have to complete the diagram as well, people. So the secondary storage, the categorization should be there on the book. So this is a video about the hard disk, right? And let me share it with the sound. Yes, I have paused the video on here to show you some things. So these are the inner side of a hard disk, so which we call an IDE type of hard disk, right? So this is what you call, like I told you, there are many movable parts. So this is the major moving part, which we call the actuator arm, right? Now, like at the edge of this actuator arm, you got the head, right? I told you that to read things from a magnetic medias, we need a head. So head is right over here, and this CD type of a thing is called a platter, and it has the ability of writing the data on both the surfaces. උඩයි යටයි දෙකේම data write කරන්න පුළුවන්, right? And these platters, there are many number of platters, like 2 or 3, and these platters are connected connected with this spindle at the middle. Spindle එක කියන එකෙන් තමයි දැන් හරියට ඔයගොල්ලන්ගේ ඇඟිල්ලට ඔයගොල්ලෝ දබර ඇඟිල්ලට CDs දෙක තුනක් දැම්මෙන් පස්සේ ඇඟිල්ල කරකවනකොට CDs ටික කරකවනවානේ. So the same happens here. So spindle is intact with the platters, and when the spindle rotates, the platter rotates. So if some data to be read, what will happen is this platter will turn to the appropriate place, and the this head will go up and down to read what's on that particular place, right? So it's moving, the parts are there to move. So whatever it is being read will be communicated through this circuit, right? So that's what happens, right? Yeah, and these pins, now there are like three types of or like three places which have this golden color or like the copper type of pins and silver color pins. Now this particular big socket, this is a one big socket, and it is called the IDE connector. So that is why this hard disk is called the IDE type. This hard disk has the connectivity over the IDE connector. So IDE connector will be connected with a data cable. Data cable එක උතන්ට තමයි plug වෙන්නේ. හරි, data cable එක පොඩ්ඩක් ප්‍රමාණයෙන් ලොකුයි. සාමාන්‍යයෙන් අඟල් දෙකක් විතර පළලයි. Right, ash color one. If I had a chance, I'll bring you one in the next class. Right, so they fix it to the this particular socket, one end, and the other end will be fixed into the motherboard, right? So that will be used to communicate the data from the hard disk onto the motherboard, where the RAM, CPU, and all these things have been fixed. These silver color knots, it is there to connect with the power supply. Yeah, the current supply කරන්නේ මෙතනට, right? And this small place, we call it the jumper area, right? It is used to like change the primary and secondary option of a hard disk, which is something little complex to you. So don't worry about it. Just remember this IDE connector and the power supply. So that is how the data is taken and the power is given to the hard disk, right? Yeah, so that will be the end. So that is the nature of a hard disk, right? So by next week, we will be going through these particular things, right? Then we'll take those things into our note. So complete the things, right, people? So you need to draw this diagram at home if you are not drawn it already. So we are going to meet online, not online, right? Offline in Nanapetha Institute hereafter, right? So physical class will be begin by next Friday from 6 to 8, right? So remember the time, spread the word, right? We will be meeting by next Friday, right? So I'll bring you some hardwares to see how the things are happens in the computer, right? So people, I'll see you soon, right? So I'm ending the session for today, right? So thank you very much. We'll meet at Nanapetha by next week, right? So thank you very much, people. Have a good night. I'll see you on next Friday, right? Okay. Good night, everyone.
Thank you, sir.
Okay, Dua. Thank you very much.